Come to the session continuation for chapter 2, that is error analysis. Okay, in the last session we've seen what exactly absolute error and limiting error, and that is percentage error analysis, and observations also I explained. There is one more concept with respect to error analysis that is important for any competitive, that concentrate write down error due to combination of quantities. Yes, error due to combination of quantities. How to do the error analysis in combination of quantities. Yes, what do you mean by error due to combination of quantities means? That is how to do error analysis in addition of quantities, subtraction of quantities, multiplication of quantities, and division of quantities. The first one is error due to sum of the quantities. Sum of the quantities. Yes. Let's assume that in a particular experiment we are measured some readings, but in that experiment I will get resultant is by adding all those readings, but in the measurement of every reading there is some error is there. Then what is the error in the resultant? In that application this analysis is useful. Okay, let's assume that in a particular experiment x equal to x1 plus s, x2 plus and so on plus xn. Okay, then here I am explaining error analysis. Normal analysis, you know how to add, how to subtract, all this, you know, subtraction, addition, all this. But if errors are given, how to do the error analysis in addition, subtraction, all this. Now first I am explaining addition. Now partial differentiate both sides with respect to x. Then 1 equal to partial differentiation with respect to x. Yes, partial differentiation with respect to x. Yes, then you simplify this, what do you get? But you know that dou is very small value. Instead of dou you take delta. Then what is delta x equal to? Delta x1 plus delta x2 plus and so on plus delta xn. Delta x1 is absolute error in x1, absolute error in x2, absolute error in xn. But error may be plus or minus. This is the resultant. That means what it states, in sum of the quantities, resultant absolute error equal to sum of the individual absolute errors. Therefore, resultant absolute error equal to sum of the individual absolute errors. Yes, individual absolute errors. That is, in sum of the quantities, in addition of the quantities, which errors are added directly? In addition of the quantities, yes, absolute errors are added. We can add directly. Absolute errors are added. In addition of the quantities, absolute errors are added. Means, for example, R1 equal to 100 plus or minus 1 ohm. R2 equal to 50 plus or minus 2 ohms. Like that it is given. If it is asked to calculate R1 plus R2. In the measurement of R1, 100 ohms is measured, but it is not exactly measured. It is measured with plus or minus 1 ohm. In the measurement of R2, 50 ohms is measured, but it is not exactly measured. It is measured with plus or minus 2 ohms. Then, what is R1 plus R2? If it is asked like this, then R1 plus R2 equal to 150 plus or minus 3 ohms. Right answer. This is the proof. That means, in addition of quantities, absolute errors are added directly. For example, if it is given like this, if R1 equal to 100 plus or minus 2%, R2 equal to 50 plus or minus 1% it is given. If it is asked what is R1 plus R2, then 150 plus or minus 3%, wrong answer. Don't do like this. Why? That is, in addition of quantities we can add only absolute error, but given is here limiting errors, percentage limiting error. Then if you want to solve this problem is, you convert this limiting error into absolute error, then you can add. Like that you do. How it is solved? How you can solve? Later on we'll see in the examples. Clear? That means the final observation here, wherever error analysis we are doing in addition of quantities, in sum of the quantities, if absolute errors are given, you can add directly. Then if limiting errors are given, you convert into absolute error, then you can add. Again you convert that absolute error into limiting error. You want to tell in terms of limiting error means. Understood? Okay, this is one observation. Second observation. Error due to difference of quantities. Error due to how to do the error analysis in difference of quantities. Difference of quantities. Error due to difference of quantities. Yes. Let us assume that in a particular experiment, x equal to x1 minus x2. We are doing one experiment. In that experiment, I am measuring x1 reading and I am measuring x2 reading. But in that experiment, I will get by subtracting 2 readings. But in the measurement of x1, there is some error is there. In the measurement of x2 also there is some error is there. Then what is the error in the measurement of x? That is x1 minus x2 that you want to calculate. Take one example. We are conducting one experiment on electrical machines. We are measured input. We are measured output also. But input is not measured exactly. There is some error. Output is also not measured exactly. There is some error. But we are measuring losses. Input minus output. There is error in input measurement. There is error in output measurement. There must be error in losses measurement also. Na? You want to calculate what is the error in losses measurement. In that application, we can use this analysis. Okay. Now, tell me. Take partial differentiation both sides with respect to x. Partial differentiation both sides with respect to x. Instead of dou, you take delta. Yes. Delta x1 minus delta x2. Yes. Mathematically it is correct. Mathematically it is correct. Mathematically it is correct. Then delta x equal to plus or minus delta x1 plus delta x2. Technically it is correct. Don't take negative. You take addition. This is important. Here I am getting negative, but why you have taken this positive? This is technical. Reason is this one. There is a error in x1 is delta x1. Error in x2 is delta x2. We want to find error in x1 minus x2. In the measurement of x1 there is some error is there. In the measurement of x2 there is some error is there. We are doing another process now. x1 minus x2 is another process. Because of that process also error must be added. But what the mathematics telling here, error is reducing. That is meaningless. That's why technically you take plus only, not minus. Error, if the number of processes will be increases, Because of that extra process, extra error will be added. That's why error must be increased. That's why you take plus, not a minus. Mathematically it is correct, but technically you take plus. Understood? That means in difference of quantities also, which errors are added? Absolute errors are added. In difference of quantities also, in difference of quantities, absolute errors are added. Absolute errors are added. Means, for example, R1 equal to 100 plus or minus 1 ohm. R2 equal to 50 plus or minus 2 ohms. If it is asked what is R1 minus R2, 50 plus or minus 3 ohms. Right answer. Don't do this analysis on limiting error. If limiting error is given, you convert it to absolute, then you can do. That's why 50 plus. Normal analysis, 100 minus 50, 50. Everybody But how to do the error analysis? In difference of quantities also, which errors are added? Absolute error. We can add directly. Okay. Then third one. Error due to multiplication of quantities. Multiplication of quantities. How to do the error analysis in multiplication of quantities? Tell. Let in a particular experiment, x equal to x1 into x2. For example, in the measurement of power using voltmeter and ammeter method, we are measured some voltage using voltmeter, but there is some error. We are measured current using ammeter, there is some error. Then what is the error in the measurement of power? Power is nothing but V into I. In that application, we can use this analysis. Okay. Then to simplify this, take natural logarithm on both sides. Then what we get? ln of x equal to ln of x1 ln of x1 plus ln of x2. Partial differentiate both sides with respect to x. Then 1 by x equal to 1 by x1. Partial differentiation with respect to x plus 1 by x2. Then what we get? Instead of though, you take delta. Yes, delta x by x into 100 equal to, error may be plus or minus, delta x1 by x1 into 100 plus delta x2 by x2 into 100. Therefore, in multiplication of quantities, resultant limiting error equal to sum of the individual limiting errors. That means multiplication of quantities, which errors we can add? Limiting errors, not absolute errors directly. Understood? Therefore, percentage limiting error in x equal to plus or minus percentage limiting error in x1 plus percentage limiting error in x2. Therefore, in multiplication of quantities, in multiplication, limiting errors are added. Limiting errors are added. If any absolute errors are given, you convert into limiting errors, then you can add. For example, V equal to 50 plus or minus 2%, I equal to 10 plus or minus 1%. Then what is V into I? V into I equal to 500 plus or minus 3%. Right answer. If it is given like this, V equal to 50 plus or minus 2 volts, I equal to 5 plus or minus 1 ampere. What is V into I equal to 250 plus or minus 3 watts? Wrong answer. Don't do like that. If it is in absolute form, you convert into limiting form, then you can add directly. That is important. That's why in error due to multiplication, which errors are added? Limiting error. Quick note down. But point to remember, this is applicable without any addition term and subtraction term. In this multiplication, there is no any addition term, there is no any subtraction term. Then only this concept is applicable. Limiting errors are added directly in multiplication. There is no addition term, there is no any subtraction term, only multiplying terms only. Then only it is applicable. This also x1 square into x2, that is also applicable, but there is no any addition term and subtraction, then it is applicable. Sir, if there is addition and subtraction term in the multiplication also, how to do means, then go for normal procedure only. Simplify that, apply partial differentiation both sides, then you can simplify, then whatever the answer you can get, in that you can substitute. That is the way to do. You start from starting. But if it is in this form, not start from starting, directly you can add. Understood? Then fourth one is error due to division of quantities. That you concentrate. Error due to division of quantities. Yes. Tell. In a particular experiment, let x equal to x1 by x2. For example, we are conducting an experiment on electrical machines. We are measured output, there is some error in the output. We are measured input, there is some error in the measurement of input also. Then we are measuring efficiency, output by input. Again, what is error in the measurement of efficiency that you want to calculate? Then you go for this analysis. Okay, tell. To simplify this, take partial differentiation, take natural logarithm on both sides. Ln of x equal to ln of x1 minus ln of x2. Partial differentiate both sides with respect to x. Then what you write? 1 by x equal to 1 by x1 into dou x1 by dou x. Partial differentiation of x2. Shall you write like this? Instead of dou, you take delta. Yes, mathematically it is correct. What the mathematics is telling? Error is reducing. Error is reducing means meaningless. If number of processes are increases, error must be increases. Then technically you take like this. Therefore, limiting errors are added. In division of quantities also, limiting errors are added directly. That is, resultant limiting error equal to sum of the individual limiting error in division of quantities. In multiplication also, resultant limiting error equal to sum of the individual limiting errors. Don't take negative. Mathematics telling that there is some error in x1, there is some error in x2. In the measurement of x error is reducing. That is meaning error reducing means meaningless. The number of process will increases, error is increased. That's why we take place. Yes. But this is also applicable. There is no addition term, there is no subtraction term. Then only this directly we can add. For example, x1 by x1 plus x2 form is there. Then this is not applicable, this method. Then you can do from starting itself. Simplify that. If x1 plus x2 by x2 form is there, then this is also not applicable. This is applicable. There is no, for example, like this, x1 x2 by x3 is there. Then this is applicable. There is no any addition and subtraction term. Then only this method is applicable. That point to remember. Okay. Then fifth one is error due to composite factors. Error due to composite factors. Yes. Listen please. In a particular experiment, x equal to x1 power m, x2 power n, x3 power p. If it is like this, then what is the resultant in the measurement of x? If you want to simplify this one, take nature logarithm on both sides. What do you get? ln of x equal to m into ln of x1 plus n into ln of x2 minus p into ln of x3. Partial differentiate both sides with respect to x. Then 1 by x equal to m into s 1 by x1 into dou x1 by dou x plus n into 1 by x2 partial differentiation of x minus p into 1 by x3 into partial differentiation of x3. Then what you write? This equal to m into by x1 plus n into dou x2 by dou x minus p into partial differentiation of this is x2, this is x2 and this is x3. But you take delta x by x equal to plus or directly I am writing m into delta x1 by x1 into 100 plus n into delta x2 by x2 into 100. Even though minus is there, you take plus technically. This is technically you take, because error reducing means meaningless. This is technically I am writing. Don't confuse, even though it is minus is there, I am writing plus p because error must be added. Error subtracted means meaningless. Error reducing means meaningless. That means, what is the observation here? In composite factors, power becomes a multiplying factor for which error? Limiting error. Power is multiplied for limiting error. That is, power becomes multiplying factor for limiting error. This observation important. What is the meaning of this? For example, R1 equal to 100 plus or minus 2%. What is R1 power 5? It is asked. Then how to solve? 100 power 5 directly you write plus or minus. Power becomes a multiplying factor of limiting error into 2%. 100 power 5 plus or minus 10%. Right answer. It is multiplied for limiting error only, not absolute error. Point to remember. If it is given here, it is absolute error. You convert into limiting error, then you can solve this. Understood? This you know. quick. Yes, listen. Okay, this about the finally 3 points you remember here. One is in addition and subtraction, absolute errors are added directly. That one point you remember. In multiplication and division, limiting errors are added. In composite factors, power becomes a multiplying factor of limiting error. These 3 points you remember. Now with this knowledge, okay, in detail different types of questions I will solve in the classroom workbook, but to know this concept, just I will give 2 examples. By using that 2 examples, then we get clear idea how to do the analysis in multiplication, division, addition and subtraction. Okay, see the 2 examples I am explaining here. This is not classroom workbook questions. This I am giving to understand this concept only. Over? Yes. Yes. See the one example. If R1 equal to 40 plus or minus 1 ohm, R2 equal to 20 plus or minus 2 ohms. It is given like this. First one. Can you tell what is R1 plus R2? How to do this? How to do the addition? 40 plus 20, 60. Given is absolute error because it is given in ohms. Okay. Then this is 3 ohms. In addition, absolute errors are added directly. Can you tell what is R1 minus R2? R1 minus R2 equal 40 minus 20. 20. In subtraction also absolute errors are added directly. Write like this. Then if you want to do multiplication, division and composite factors, means you convert into absolute into limiting. Then how to convert absolute to limiting? Absolute to limiting error. Yes. I want to find what the percentage limiting error in R1. Percentage limiting error in R1 is delta R1 by R1 into 100. But no need to write the formula also. Absolute error by true value into 100 gives the limiting error. No need to write the formula also. Error by true value into 100. What is the error? Plus or minus 1 by 40 into 100. Then how much? Plus or minus 2.5%. Yes. What is the percentage limiting error in R2, you tell me? Percentage limiting error in R2 equal to delta R2 by R2 into 100. What is delta R2? Plus or minus 2 by R2 is how much? 20 into 100. How much we get? Plus or minus 10%. Okay. This is 2 ohms by 20 into 100. How much we get? This is 5 times. Plus or minus 10%. By knowing the limiting error in terms of percentage, then by knowing the limiting error, how to write R1 equal to 40 plus or minus 2.5%. How to write R2 equal to, yes, how to write R2 equal to 20 plus or minus 10%. Now third one. What is R1 into R2? You tell me. Here we are getting idea how we are converting absolute to limiting. Absolute to limiting. That you concentrate. Then what is R1 into R2? 800 plus or minus 12.5%. Fourth one. What is R1 by R2? You tell me. R1 by R2 equal to, this is 40 by 20 na 2 plus or minus 12.5%. In multiplication and division, limiting errors are added directly. What about the fifth one? Can you tell what is R1 square? R1 square means, what is R1? 40 plus or minus 2.5% whole square. Then how much you get? 1600 plus or minus 5%. This power becomes multiplying factor for limiting error because it's a composite factor. 2 into 2.5 is how much? Plus or minus 5%. Like this we can solve. How to do the error analysis in addition, subtraction? How to do the error analysis in multiplication, division and composite factors? If absolute errors are given, you convert into limiting errors, then you can do. This is one example. Clear? Quick. Note down. Then here we are getting some idea. Whatever the concept I explained, how we are applying that concept here. Different models that you will see in the classroom workbook. See the example 2. Yes. For example, if R1 equal to, yes, 40 plus or minus 1%. R2 equal to, or 40 plus or minus 2%. R2 equal to 10 plus or minus 1%. If it is given like this. R1 equal to 40 plus or minus 2%, R2 equal 10 plus or minus 1%. Then how to calculate R1 into R2, you tell me. R1 into R2 equal to how much? Yes. 40 into 10, 400 plus or minus 3%. Correct? Limiting errors are added directly because it is a multiplication. What is R1 by R2, you tell me. What is R1 by R2? R1 by R2 equal to, then how we can write 4 plus or minus 3%. Then what is R1 square? R1 square equal to 40 plus or minus 2% square. Then 1600 plus or minus 4%. 1600 plus or minus 4%. Then convert percentage, limiting to percentage to absolute form to solve remaining. How to write absolute error in R1? Absolute error in R1 equal to 2% of 40. That is plus or minus 2 by 100 into 40. Concentrate how you are converting percentage to absolute. How much you get? Plus or minus 0.8 ohms. What is absolute error in R2? Yes, absolute error in R2 means 1% of 10. 1% of 10 means plus or minus 1 by 10, 1 by 100 into 10. Then how much? Plus or minus 0.1 ohm. Yes. After converting into absolute form, what is R1 equal to, you tell me? 40 plus or minus 0.8. What is R2? 10 plus or minus 0.1. Now you tell what is R1 plus R2. This is fourth one, take. What is R1 plus R2 equal to? 50 plus or minus 0.9. If you want this, again you convert into percentage form also. If you want to convert into percentage means 0.9 by 50 into 100, that you can get in percentage also. Yes. What is R1 minus R2? R1 minus R2 equal to 30 plus or minus 0.9. In subtraction we can add absolute error. In addition also we can add absolute error. This is two models of question. With this knowledge you remember up to now, remaining that you will see in the classroom workbook. Note down quick. Yes. So one note to remember here. For example, two resistances are connected in parallel, like that it is given. How to do the error analysis? Yes. You write as a note. If R1 and R2 is connected in parallel, let in the measurement of R1, absolute error is delta R1. In the measurement of R2, absolute error is delta R2. Or in the measurement of R1, limiting error is percentage limiting error is that is delta R1 by R1, that is percentage limiting error, that is delta R1 by that percentage epsilon R1. In the measurement of R2, percentage epsilon R2. We may expect error in terms of percentage, we may expect in terms of absolute. The two resistances are connected in parallel means R equal to R1 R2 by R1 plus R2. Na? Then you can find R1 R2. Directly we can add limiting error. Absolute errors are given. If limiting errors are given, you convert into absolute error, then you can do this one. Okay. Then again you can convert into limiting error. Then this is limiting error, this is limiting error, add this one. Like then you can get answer. Then absolutely that is wrong. Don't do like that. What I am telling, if it is like this, what you are trying to solve like this na? Multiplication, we get answer in limiting error. Addition, absolute error. Again you convert into limiting. This is limiting, this is also limiting. Division, we can add. That is meaningless. I told. In division we can add limiting error. There is no addition term and subtraction term. But here in denominator there is addition term is there. That's why don't apply that method directly. Then how we can simplify in parallel connection? Yes, this you follow. You start from concept itself. If the two resistances are connected in parallel, 1 by R equal to 1 by R1 plus 1 by R2. According to concept only you can solve. Then partial differentiate both sides with respect to R. Then what you can get? Minus 1 by R square equal to minus 1 by R1 square into dou R1 by dou R. Minus 1 by R2 square into dou R2 by dou R. Partial differentiate. Then negative is cancelled. Then what you can get? Dou R by R square equal to then dou R1 by R1 square plus dou R2 by R2 square. Then you take, instead of dou you take delta. Delta R by R square equal to delta R1 by R1 square plus delta R2 by R2 square. Then from this we calculate delta R equal to plus or minus R square into delta R1 by R1 square plus delta R2 by R2 square. Okay, you substitute R value. What is R here? R equal to R1 R2 by R1 plus R2. Calculate R value, substitute delta R1 delta R2 here. Then you can get the value in terms of absolute. If it is given in absolute, directly substitute here. Even it is given in limiting, you convert into absolute, then you substitute here, then you can get formula in terms of delta R. That is in terms of absolute form directly you can get. No sir, I want the formula in terms of directly percentage. After converting absolute also, we can convert into percentage, no problem. Once again you want to simplify, this means like this also you can write delta R by R equal to R into, that is R by R1 into, shall we write like this, plus or minus R by R1 into delta R1 by R1 into 100. Still I don't write into 100, next step you write. Shall we write like this, R by R2, yes, R by R2 into delta R2 by R2. Then multiply both sides by into 100. Delta R by R into 100 equal to plus or minus R by R1 into delta R1 by R1 into 100. This is the limiting error in R1. You want to substitute directly in percent means like this also you can write the formula. Then what you can write, plus R by R2 into delta R2 by R2 into 100. Then in this you substitute, then you can get the answer in terms of percentage. No sir, I want to solve only in absolute. You can directly substitute here. Then after you convert into limiting, that is in percentage form, you can get same answer. Okay. If it is given in parallel connection means, if any number of resistances are connected, like this only follow, 1 by R1 plus 1 by R2 plus 1 by R3 and so on, then partial differentiate, right, like this. You substitute that values here, you can get the error in. But don't do directly, because absolute errors, that is percentage errors, are added in multiplication and division. That concept is applicable only, there is no addition and subtraction term, then only it is applicable. Here there is addition term in denominator, that's why that method is not applicable. We can do directly like this, we can get the error in terms of percentage, or if you want to get the error in terms of absolute, you can write, after that also you convert into percentage. After getting percentage, you convert into absolute also, no problem. Okay, so this is about error due to combination of quantities. These points you remember with respect to error due to combination of quantities. Yes, clear? Next, remaining two theory concepts are there with respect to error analysis. After discussing those two theory concepts only, then I will start with the theory concepts. One is theoretical concept and another one is a numerical based concept. One is errors in the measurement system, that is what is gross error, what is systematic error, what is a random error, what are the examples, that is one concept. Then how to do the statistical error analysis, that is the another concept. After discussing that concept only, then we go for classroom workbook based on error analysis. Clear? Understand? This is one important concept. Okay, in the next session we will continue with that concept. Then after that we go for classroom workbook based on error analysis. Okay, thank you. In the next session we will continue.